The electric hair clipper was invented in 1919. It was the first clipper with a motor in the actual unit, allowing the barber to cut hair at quite a clip. Hairstyles may change, but this device is still on the cutting edge. These days, hair clipper casings are made out of heavy-duty plastic. An automated mold melts and shapes the plastic material into casing parts. Meanwhile, a robot picks up brass contacts and places them in fixtures. A plastic switch is then attached to each contact. A blast of air sends the assembled piece to a bin. Here, a robot slides a plastic spool onto a mandrel, then anchors copper wire to it. The wire is wound around the spool more than 2,000 times to make part of the electric relay that will drive the blades. Pulleys keep the wire fed at an even tension. Next, robots work on the clipper's lower casing. One installs a blade slide for adjusting the blade, and another attaches the lever that controls that slide. An automated screwdriver fastens everything together. The clipper assembly is then on its way to have a metal arm installed. This piece will move the cutting blade, and for that, it will need a couple of springs. Next, the switch assembly goes in, and then the arm is screwed into place. Workers install a screw for adjusting the power setting. And now they fit the copper wire coil into the lower housing where it will drive that metal arm. A power cord is run from the switch to the coil. And now the clipper's inner workings are complete. Over at another station, a punch press stamps out clipper blades. The blades are toothless to start. But after a good washing and heat treatment, they head over to another station to get some teeth. A worker pops a blade into a fixture to hold it steady. Then a jagged cylindrical cutter carves the teeth. Coolant keeps the process from overheating and compromising the integrity of the steel. Each hair clipper has two blades. The first one has cutting teeth which moves over the second, a larger stationary blade that ensnares the hairs so that they can be cut. Next, the company's logo is printed onto the clipper's lid. And the lid is attached to the casing that holds the electrical components. Workers mount the blades on the head of the clipper for that double-edged cutting action. And finally, each clipper is tuned for optimum performance by adjusting that power screw that was installed earlier. These clippers come in a kit that includes some additional accessories for those consumers who want to try their hand at a little home grooming. Now, these electric hair clippers are ready to get buzzing. With those sharp blades, they'll make short work of any hairy situation.
The The need to hammer things goes back to prehistoric times, when early man used stones as tools. The modern hammer evolved from those first crude implements, but with its forged steel design and user-friendly handle, the hammer of today is strikingly different. No one-hit wonder, the modern hammer is made to endure. It maintains its structural integrity despite repeated pounding and pulling. It starts with a thick steel bar. An automated system loads it into an induction furnace, set at more than 1800 degrees Fahrenheit. The fierce heat makes the steel malleable. This forge hammer pounds the hot steel into a series of hammer-shaped impressions. Then it's into a punch cutter which trims the ragged edges of the forged steel. The cutoffs go into a bin for recycling. A worker sandwiches the newly trimmed shape in a press that fine-tunes the shape. The hammers cool down on this revolving rack. Then they load the hammers into a tumbler along with tiny bits of steel. So tiny they're hard to see, but their impact will be very noticeable. As they toss about, the bits rub off scale and debris on the hammers for an impressive cleanup. They then clamp the hammer in a device that spins it against abrasive belts to contour the striking head. These belts also bevel the hammer's head. It's a safety feature. The sloped edge is less likely to chip nails on impact. Now, this jagged cutting wheel carves ridges into the hammer's head. The device repositions the hammer so the wheel can cut it in a different direction to create a grid. This surface is less likely to slip off nails on impact. Next comes the tempering process. The hammers plunge into a very hot bath. Then they dip them in quenching oil, which cools the metal so quickly it hardens. Now it's time for another polish. This one makes the steel gleam. It's the finishing touch. Next, they assemble leather rings in a tray, 25 to each one. They place plastic rings at each end to break up the look and buttress it with a prong metal disc. They slide the tray into a compartment and insert the end of the hammer in the rings. A hydraulic tool rams it through them, encasing the handle in a neat wrap that's comfortable to grasp. They secure the end of the hammer in a clamp, and then a spinning tool flattens the prongs that protrude from the metal plate, riveting it to the leather wrap. Then, using a series of sanding belts, they smooth the rough leather for a seamless finish. This is a tank of heavy lacquer in which they immerse the hammers repeatedly. When it dries, the lacquer will give the leather wrap a tough, sleek finish, and the leather will look like one textured piece instead of many. For a different kind of handle, they pour liquid vinyl on the hammer shaft that's encased in a mold. The vinyl adheres to the hammer as it hardens. The mold leaves a dimpling impression that will make the hammer easier to grip. They grind off the hardened vinyl spillover and contour the handle. These handles are preferred by some tradesmen because the vinyl is an anti-shock material. They stamp the model number onto it. Paint guns mist the steel with lacquer for a little rust proofing. The hammers then travel through an oven, which cures the lacquer. After they stamp the company logo onto the vinyl, each hammer is visually inspected. Only then does it get a seal of approval. It takes about a day to make a hammer, and with the different handle wraps and sizes, they've really nailed it. Handbells can be seen in church choirs, schools, and ring concerts. There, skilled ringers read music similar to a piano score, playing all the notes found on a modern musical keyboard. Finely crafted and tuned, handbells will continue to entertain generations to come. Handbells have a long tradition of making beautiful music, from church hymns to the music of Beethoven. It all starts with a casting mold that a worker encloses in a two-part container or flask. He fills the bottom half of the flask with special coarse sand that's ideal for making sand molds. He compacts the sand and then he turns the metal flask over. He places guide rods onto the bell shapes and fills the top part of the flask with sand. He puts a ramming board on again, and he compacts the sand that fills the top part of the flask. Now he removes the guide rods. Then he removes the top half of the flask and takes out the casting mold. He reconnects the top of the flask and then frees it completely from the sand mold. A worker places bronze ingots into a crucible to melt them down. He places heat-sensitive material onto the sand mold and then heavy weights to hold the mold together safely. When the melted bronze reaches about 2200 degrees Fahrenheit, a worker guides the crucible over to the sand mold and pours the molten metal into the cavity of the mold. He stops pouring when he sees the heat-sensitive material smoking. This indicates the mold cavity is filled. Workers then use a vibrating bed and small hammers to free the finished castings from the sand mold. Rotor blasting cleans the dirty castings. A worker trims off the excess pieces that feed the molten metal into the bell cavity. He sands the sharp edges of the bell and then drills the center hole for the assembly screw. The bell casting then goes on a lathe. Here, a carbide cutting tool, working with a stylus that follows a template of the bell, removes the coarse casting surface and makes the bell shiny. This turning operation also shapes the bell to give it the right tone. Another carbide cutting tool shapes the inside of the bell casting, giving it shine and the desired tuning as well. Using a custom-made tracing device, a worker reproduces the outside shape of the bell on paper. He then traces the inside of the bell casting until he completes an exact replica of the inside and the outside shape. And this must match a master template. A worker polishes the bell using fine sandpaper. He also puts a jeweler's finish on the inside. Then he tests the bell's sound quality using a stroboscopic tuner and the human ear. He resands the bell to make a slight tonal adjustment. Then he tests it again to make sure it strikes the perfect musical note. A worker gives the bell that final polish, and another craftsman engraves the bell for the customer. Finally, a worker puts the ringer and bell together. She puts a washer, a hand disc, and a handle onto the assembly screw and screws it all into place. Handbells make wonderful music in the hands of skilled ringers, whether the musical compositions are performed by an intimate gathering of friends or by a concert bell choir of 13 ringers or more. The music made by traditional handbells is timeless. In the early part of the 20th century, headphones were used mainly by telephone operators and radio technicians. But in the 1930s, they were redesigned and marketed to the public, so music lovers everywhere plugged in and turned on to the concept. Everyone is a music critic, but headphones allow people to crank up the volume without negative feedback from neighbors. To make high-end headphones, an injection molding machine first makes plastic back covers. The mesh area will allow sound waves to pass through instead of reflecting back into the headphone. Down the line, equipment stamps trademark and other information onto two more casing components, a decorative metal disc and a plastic housing. The next machine winds copper wire that's as thin as human hair around a cylinder hundreds of times. The winding is computer controlled to produce a critical component, the headphone's voice coil. When magnetized by an incoming signal, the voice coil vibrates a diaphragm, causing it to emit sound. That diaphragm now takes shape as a press applies heat and pressure to a plastic membrane. These tools mold the plastic to the desired shape. The press molds the plastic thicker in the center and thinner around the outer zone for a wide and flat audio frequency range. A technician punches out the molded shape. She applies a bead of glue to the diaphragm, then positions the copper voice coil in an assembly device. She aligns the glued section of the diaphragm with the coil. Ultraviolet light activates the glue to seal the coil to the diaphragm. The plastic housings each contain a magnet. The next technician installs the diaphragm and voice coil assembly on that housing. This takes skill because the coil must be positioned precisely for the best sound quality. And this headphone speaker is now ready for an audio check. A technician tests the audio frequency range, distortion, and other factors. Here a technician joins the ends of curved wires in a plastic clip. These wires serve a dual function. They hold the headphones snugly over the ears and deliver audio signals from the left side of the headphones to the right. The next technician installs a connector for the headphone's audio cable and a plastic strain relief. An adjustable band will allow the headphones to fit on heads of all shapes and sizes. The operator presses the parts together with a hydraulic tool. Moving down the line, a technician now joins the two halves of the speaker housing. She forces the two parts together with the pneumatic tool and finishes it off with a decorative metal ring. She inserts the speaker mechanism in the center of the housing, then places plastic brackets over it for protection. She then secures the entire assembly to the housing. Next, she solders two wires to each headphone speaker. A plastic ring and cover protect it while still allowing the wires to protrude. She attaches the end of the headband to the speakers. Then solders the wires from the speaker to those protruding from the headband. She presses a plastic grill into place over each speaker, very carefully to prevent scratching. These headphones are now wired and ready for audio. And whether it's rock or classical, the choice of music will be silent to all but one individual. Heart of palm is a vegetable that comes from certain species of palms. It doesn't grow on the plant the way fruits and vegetables usually do. Rather, it's the soft, edible inner core of the stems. Harvesting palm stems and then processing them to extract the heart is very labor-intensive, which is why this delicious vegetable is a delicacy. Life for this tropical vegetable begins in the farm's nursery, where they plant a palm seed in a pot of soil. After a couple of weeks, they transplant the seedling into a bag, and the seedling grows. Life in the nursery is one of routine, scheduled feedings of fertilizer, regular weeding, and a daily shower. After about 3 months, that little seedling has matured into a plant that's strong enough to go into the field. Workers remove it from the bag gently, careful not to harm the roots, then they plant it in loose soil. After about 1.5 years of field growth, it's time for the first harvest. Using a machete, the harvester grabs and chops off the main stem. One of the remaining smaller stems will become the new main stem and be ready for harvesting in about 6 months' time. This cycle continues for about a decade. After cutting off the stem, the harvester strips the bark. This exposes a shell underneath that protects the palm heart at the core of the stem from damage and dehydration. Later, the factory will slice off this shell, like so, to extract the heart. Once the stems arrive at the factory, they go into a basin of water immediately. This prevents dehydration. Next, workers load them on a conveyor belt, lining the bases right up against the edge. Someone else, meanwhile, clicks a counter to tally the number of stems passing by. The conveyor belt transports the stems to a circular saw that slices off a portion of the base. Next, workers slide each stem across a razor-sharp blade, slicing open the shell that encases the heart. With a quick twist, the shell comes off, and they place the heart on a conveyor above. Further down the line, the hearts run against another circular saw, which slices off what's left of the base. Next, a row of saws spaced 6 inches apart cuts each stem into pieces. Now the hearts of palm are just the right size for packaging. In the field, the stem's bark and outer shell acted as a dirt barrier. Still, the hearts get a rinse in cold water before going into the jar. Each jar has to contain a specific weight and number of pieces, so it goes on a scale, and if necessary, a worker adjusts the weight by swapping a piece for one of a different size. The jars now move on to a machine that fills them with brine, a special recipe of water, salt, and citric acid that acts as a preservative. The brine-filled jars then go into a hot steam machine. It heats the liquid for about 10 minutes, almost to the boiling point. This forces all the air out of the hearts, preparing them for pasteurization. On the way to the pasteurization chamber, the jars pass through a capping machine. Then under an inkjet printer head, which applies the lot number and product expiration date. Now it's into the pasteurization chamber for an hour and a half. This intense heat, 207 degrees Fahrenheit, kills off any microorganisms lurking inside the jars. After a 1-week quarantine period, to ensure the hearts of palm don't deteriorate in any way, the jars are ready for labeling. The brine and pasteurization combined give the sealed container a 4-year shelf life. So whether served alone, in a salad, with pasta or rice, these hearts of palm are guaranteed to be as fresh as they are tasty.